In 2024, Apple canceled Project Titan, the autonomous vehicle that had consumed hundreds of millions of dollars and a decade of engineering effort. Within months, reports emerged that the same team, the same research, and the same ambition had quietly pivoted to something entirely different: domestic robotics. Apple had not abandoned automation. It had simply realized that the real frontier was not on the road. It was inside the home. And the company is building a robot that will fundamentally change how people live. For decades, the robotics industry has chased a single dream: humanoid robots that can perform arbitrary tasks in unstructured environments. The engineering challenge is staggering. A robot must perceive its surroundings in 3 dimensions, understand spatial relationships, plan motion in real time, and execute physical tasks with precision and safety. For decades, this remained speculative, but something fundamental has changed in the past 3 years. The convergence of advances in spatial computing, custom silicon, machine learning, and mechanical engineering has made something possible that was not possible before. A robot designed for the home that is actually useful. Apple's robotics division is not building a general-purpose robot for an imagined future. It is building a purpose-built machine for a specific challenge that consumers face every day: the gap between what they need done and what they have time to do. The cancellation of Project Titan was not a failure of execution. It was a recalibration of vision. Apple engineers had spent a decade solving the problem of autonomous vehicle control: LiDAR sensing, real-time environmental modeling, motion planning in dynamic spaces, and safety validation at highway speeds. But the automotive market was consolidating. Tesla had already dominated the space. The regulatory environment was becoming hostile to new entrants, and the profit margins did not justify the capital expenditure. What Apple did have was something more valuable: a decade of research into autonomous motion, spatial perception, real-time computing, and embodied AI. These capabilities were not specific to vehicles. They were fundamental to any robot operating in complex environments. The home robot market was entirely different. There was no dominant player. The barriers to entry were not regulatory or capital intensive. They were technical. A company that could solve the core engineering challenge would own the market. The architecture of Apple's robotics platform combines 4 distinct technological advances, each of which has only recently matured to consumer readiness. First is the M-series chip. The custom processors that power the Mac and iPad have been redesigned with specialized neural accelerators capable of real-time vision processing. The 2026 M5 generation includes dedicated silicon for 3D spatial reasoning and kinematic planning, the computational bottlenecks of robot motion. Second is the sensor fusion system, a combination of LiDAR, ultra-wideband imaging, and wearable spatial sensors creates a persistent, high-fidelity digital twin of the home environment. The robot understands not just where objects are, but how they are oriented, how they move, and how humans interact with them. Third is the mechanical design. Apple's desktop robotic manipulators have been engineered for safety alongside precision. The limbs move with deliberate slowness. The forces are limited. The joints can sense contact forces in real time. Every interaction with a human or fragile object is monitored and adapted on the fly. Fourth is the on-device AI. Unlike competitors who rely on cloud processing, Apple's system reasons about tasks entirely locally. The privacy implications are profound. The robot does not send video feeds or task data to remote servers. Every decision about what action to take happens inside the home. Apple's initial robotics platform is not designed to be a general-purpose humanoid. It is purpose-built for specific household tasks where precision and consistency matter. Kitchen organization, laundry management, tidying and sorting, preparation of repetitive manual tasks. The platform is modular. Different end effectors, different gripper types, different tool attachments allow the same base platform to be reconfigured for different tasks. Over time, this modularity becomes a platform. Third-party developers can build specialized tools for specialized problems. The robot learns from interaction. Unlike previous robotic systems that required explicit programming for every new task, Apple's system can observe human demonstration and generalize to new environments. The homeowner can show the robot how to perform a task once, and the robot understands the principle and adapts. This is the distinction between robots that are tools and robots that are assistants. Apple is building the latter. The smart home market today is fragmented and primitive. Connected devices that do single tasks: a smart lock, a smart light, a smart speaker. These devices exist in isolation. They do not understand each other or the broader context of the home. A robot that can understand the state of the home and act physically transforms this entirely. The smart home does not become a collection of disconnected devices. It becomes a single integrated system with the robot as the physical layer. This is the same pattern that defined the smartphone era. The phone was not the first pocket-sized computing device. It was the device that integrated everything and made the ecosystem cohere. Apple's robot is designed to be that device for the home. And like the iPhone, it will lock users deeper into the Apple ecosystem. Devices that integrate with the robot have to speak Apple's language. Services that work with the robot have to follow Apple's rules. The install base of smart home devices becomes, over time, Apple smart home devices. The timeline for Apple's robot suggests a commercial release window sometime in late 2026 or 2027. Supply chain contracts are being locked. Component sourcing is being formalized. The intellectual property filings have accelerated. The infrastructure required to bring this product to market at scale is assembling in parallel. This is not the end of the story. It is the beginning. The first generation will be followed by cheaper variants, more capable variants, and variants specialized for different use cases. What starts in the high-income American market will expand globally. The market opportunity is not the robot itself. It is robotics as a service. Apple will eventually offer the robot on a subscription model, bundled with software updates, new capabilities, and insurance. The recurring revenue from robotics could rival the recurring revenue from services today. The history of consumer technology moves in waves. The personal computer wave was about placing computational power in individual hands. The smartphone wave was about making that power portable. The next wave is about making that power physical. Apple has spent a decade building the robotics platform that makes this transition possible. The product is not a gadget. It is the foundation for how humans will live in smart homes for the next generation. The robot is coming, and everything that assumed static physical space will have to rethink what that means.